In this lesson, we get our mathematical definition of torque. We get our mathematical structure to calculate torque and answer our homework questions with. So we're going to see that cross product. Torque given by the mathematical equation R cross F does it all for us, right? So we don't have to worry about sorting out lever arm distance, force tangent, what do I do? Please, please, please put this down to your notes. What are you going to do? What do? You use R cross F to calculate torque. You go back to becoming a cross product machine. Yes, we start every torque rotation problem by identifying the pivot point. The R vector is the vector from the pivot point to where the force acts along the plank. So that's the vector R. The force F is whatever force is acting to cause the rotation. So that's the force F. You are going to draw them from a common origin, as we always do for cross product, which generally means you're going to take the R vector and slide it forward to have your common origin here, or you can take the F vector and slide it backwards to have your common origin here. You get the same thing. So either way you do it, you draw them from a common origin. You do R cross F. We'll always be working in the plane of the page, so you're either going to be karate chopping or reverse karate chopping. So your index finger basically is going to be the vector R, and you're going to point your index finger of your right hand in the direction of vector R, either in a karate chop position or a reverse karate chop position. You're going to make a fist, and you're going to stick your thumb out, which will be out of the page or into the page. In this case, karate chop position, perpendicular to the page. My index finger of my right hand becomes the R vector. It's pointing towards my left hand. I make a fist. I stick my thumb out. It's out of the paper, so this would be a positive z-hat torque when I do my curl, my rotation. So positive z-hat torques are going to correspond to counterclockwise rotation. Counterclockwise rotation is positive. If we look at what R cross F is doing for us, it is taking the vector R, magnitude of R, magnitude of F times the sine of the angle between the two as drawn from a common origin, and it's that sine of the angle that is taking care of our lever arm calculation or our force tangent calculation. If we associate the sine theta with the R, we get the lever arm. R sine theta is the lever arm. So if you're asked to calculate the lever arm, calculate R sine theta. If you were asked to calculate force tangent, calculate F sine theta. So cross product takes care of it for us. We don't need to wallow around in what to do and oh my goodness, I didn't understand any of this. R cross F, R cross F. So that is why on our next page of notes, you have R cross F problems to do. And it is really important that you go back and refresh your memory on how to do cross products and that you can do all of these. So basically you have 4 torques to calculate here. So we have a single plank pinned or put on a pivot at the top. So we're looking at the plane of the page. We have a force F1 here. So your R goes from the pivot to where the force acts. Your F is whatever it is. Draw them from a common origin. Take R cross F. You're going to do the same thing for F2, the same thing for F3, and then go back, do the same thing for F4, and just make sure you can calculate all of these torques. The answers are given there for you, so hopefully you can confirm them. I'll ask you to pause the video right here. Try these, and when you come back, we can unpause and you can take a look at the solutions. So pause the video. Okay, hopefully you've given these a try. If you got them right, that's great, but let's just take a quick look at the solutions. So I'm not going to go through the cross products with you, but notice it is worth taking the time to take your time to redraw them from a common origin and calculate R cross F. When you do your cross product, you'll always be thumb into the paper or thumb out of the paper. So this first one is a little tricky, right? Your index finger of your right hand is going to be in the R, but here we have to kind of reverse karate chop and really twist around and then curl in the direction of F to get our thumb into the paper to have the negative Z hat. So we'll go over these in class as well to make sure everyone is doing the R cross F and can get whether it's a positive or negative Z hat correct into the problem. But the most important thing is that you embrace R cross F and cross product to calculate torque. You don't want to have to worry about lever arm distances and force tangents. Let the equations, the R sine theta or the F sine theta, when they're drawn from the common origin, calculate that for you. So the math is wonderful. Make R cross F your torque friend. So there we have it. We'll definitely have some homework problems to look at as well, and we're going to continue on.